Hi everyone, we're going to find the radius of convergence and interval of convergence for the given series. We're going to use the ratio test, look at condition 1. So basically we're taking the limit as n approaches infinity of a sub n plus 1 divided by our given series. So this is a sub n. Alright, so let's fill everything out. We're going to get the limit as n approaches infinity, absolute value of x minus 2 to the power of n plus 1 divided by n plus 1 squared plus 1. Now we're going to divide by a sub n, which is the same as multiplying by the reciprocal. So that's going to be n squared plus 1 divided by x minus 2 to the power of n. Alright, now let's look at this. We're going to take the limit as n approaches infinity and write this as this is going to be, you reduce this, this is just going to be x minus 2, and then we're going to have times n squared plus 1 divided by n plus 1 squared plus 1. Absolute value, sorry. Now I can pull this out and write this as absolute value of x minus 2 times the limit as n approaches infinity. Divide each of these pieces by n squared, and when you do that, I'll just write it out as, let's see, n squared plus 1 divided by n plus 1 squared plus 1. So this is going to go to 1. So when you multiply x minus 2 times 1, we're going to get this equals x, absolute value of x minus 2. So it converges when absolute value of x minus 2 is less than 1. That means the radius of convergence equals 1 if and only if we have negative 1 is less than x minus 2 is less than 1. So if you add 2 to every piece, so add 2, add 2, add 2, we get x is in between 1 and 3. So now we have to find the intervals of convergence, and to do that we have to test our endpoints 1 and 3. So let's do that. When x equals 1, we get the series, the sum from n equals 0 to infinity of negative 1 to the nth times 1 divided by n squared plus 1. Now, by the alternating series test, this is convergence. It converges. All right. The limit goes to 0, and you can test that. By the way, I already did a lot of videos on these if you want to look at those as well. All right, now let's test the other endpoint, x equals 3. So when x is 3, we get the series n equals 0 to infinity of 1 divided by n squared plus 1. And we're going to compare it to the series of the sum n equals 1 to infinity of 1 divided by n squared. This number is larger, so by that method, for the p series, our p equals 2, which is greater than 1. So this means this also, this series converges. Therefore, this series converges as well, since this is greater than this series. So since they both converge, The interval of convergence is 1, 3. So that means it can equal the 1 and the 3. Thank you. Have a nice day. Bye-bye.